This mean value theorem. What time do we get done? 20.
Yeah, what did you get?
Yeah.
27. Okay, so I know I'm starting to get old because I looked at this section and I honestly thought we already did this year. And I must be remembering last year. That's the only thing I can think of because we haven't done this, correct?
No.
Yeah, all right. You're done?
Well, basically, yeah, I just have a question.
Oh, wow.
Why is that fast?
Yeah.
Because it says, like, the question is saying when it's dropping, do I need to put a negative sign?
I cannot tell you that, but that is definitely something you want to decide. I get what you're asking, I just can't say.
Okay.
So I know we had questions. I believe it wasn't called mean vet. I want to say, weren't you asked to find the average value? I think that was last unit. I believe when you had a graph, you were, maybe it was 2 tests ago. Maybe I'm thinking of the people that just did corrections on the end of 3. I feel like you had a graph and you were asked to find the average value. And the way you had to do that was to take the area divided by the width.
Oh, yeah, yeah.
Okay, so average value is talking about the average height. This is not. Even though the word mean 100% means average, right? This one, the wording, it's not like it's misleading, it's just, it makes you feel like it's doing something different. What we are gonna do is we are gonna take a beginning and an ending point, and if a function meets certain criteria, you are guaranteed that the slope, let me pick a different color. You're guaranteed the slope between these 2 endpoints will happen at least once in between somewhere.
Oh, can you please turn your screen?
We were even just talking about that. I guess we should bring that up. As you guys pick seats, make sure you pick a seat that's gonna work too, because like these 2 spots are generally the worst to be able to see the board. So I drew the slope between the 2 endpoints. And as we're looking at that curve, for this example, we can see 2 spots that will have the exact same slope. Like I can tell right about here and right about here will have the exact same tangent line slope. Now, I did start off by saying if the function meets certain criteria. That's like the big important part. So that first picture we're looking at does meet the criteria, and we'll talk about them in a minute. So the slope between the endpoints, at least one location will have the exact same instant slope. So here is the mean value theorem boiled down to, well, as dumb a language as we can for calc. It's not dumbed down language, right? It's just dumbed down for calc. Somewhere on your paper you want to write this. Average slope equals instant slope. So this is what the mean value theorem is. Is you're trying to find the location where the average slope is the same as the instant slope. Andrew, do you remember what average slope is?
Is it the y minus y not over x?
Yeah.
Yeah.
I mean, you were trying to give me an equation. I just wanted like words.
Oh.
You weren't wrong, like you were correct, that's the
Change in
equation.
slope, the change in the value.
Oh, wow. Can anybody else think how to say it for the common folk?
Would the average slope just be the average height of the derivative?
Oh, pretend you guys are in a class 2 years ago. Okay, it's the slope between the two endpoints. That's what average slope is. Average slope is gonna be the slope between 2 points. You were giving me a formula for it, which was 100% correct, okay? So now let's. You know what, my rolling system doesn't work anymore now. Well, I just said it doesn't work anymore.
I'll roll and then I'll fix it. You could just wait, can't you just pick a table, 1, 2, 3, and then?
You just roll.
You could do two, 6-sided dice, 1, 2, 3. It's a 6 with 6 rows.
Oh, yeah, it is, isn't it?
These two are, those ones are.
No, we'll call that a six.
Or you could split it down the middle and then have one, two.
Oh, too complicated. If I have to think about it, it's not happening.
Ah,
Sebastian, what's instant slope?
slope and then point.
Okay, I can live with that, that's perfect. So this is gonna be the slope at a specific location at one spot. So this is the calc slope, this is the algebra 2 slope. And that's kind of what I drew. The dotted line is the algebra 2 slope. The solid line, the tangent lines are the calc slope. If I look at the second picture, I will tell you right now, this one does not meet the criteria. And this one's kind of an example of how come this isn't guaranteed if it doesn't meet the criteria. So I've got slope between endpoints. And if I look at that picture, there is not a slope in between that matches that. This one does not fit. Here's what we would say for this problem. Mean value theorem does not apply. Now, we traditionally aren't going to use mean value theorem on a graph. We're doing this just to show you how.
It doesn't apply because it's a.
Oh, I didn't say what. Yeah, we haven't talked about the criteria yet. I'm just telling you right now that this one is an example of how come it doesn't apply. We just don't know what that is yet. I was wondering if you guys would be able to figure it out from. Okay, 3. 3, the end points are actually these, well, the ones at the end. Now, there actually is 2 locations that the tangent line meets and is matching the average slope. However, this is also an example of mean value theorem doesn't apply. That's your guess? Okay. Now, the mean value theorem, all it does is it guarantees that it will happen at least one time. So if criteria are met, the mean value theorem guarantees that this will happen at least once. Now, I'm trying to tell you that picture 2 and picture 3, the mean value theorem could not guarantee it happening. It doesn't mean it won't. That one it didn't, this one it did.
What is it?
Yeah, we're getting there. Oh, the it? The it is when the average slope is equal to the instant slope. The mean value theorem, this is the whole topic. Now, there's uses for it, but we'll talk about those when we get to it. We're just trying to talk about the theorem and figure it out. Okay, 4th picture. Okay, so the endpoints. I don't even know if I'm going to be able to draw this very well. The endpoints are right there. And the instant slope would happen right about there. And this 4th picture, mean value theorem guarantees at least once. And it happened once. Now, I could have written this on the first picture as well. So I'm trying to tell you that first picture, fourth picture, mean value theorem applies, and it guarantees it will happen at least once. The dotted line and the solid line happened on the first picture and fourth picture, and it was guaranteed. Second and third picture, it wasn't guaranteed to happen. Thanks. It wasn't guaranteed to happen, but it did happen on one of those times. Now, where we're gonna end up using this is you're going to have situations where you can't find information in between things, and you need to know if it would actually happen or not. So, in this case, so I already heard one guess that one of the criteria is that you can't have a gap. Seems like that's a fairly good guess. Okay? Other one, any thoughts on why that one didn't meet criteria?
Is a sharp point like in between the points?
Okay? What, do you remember what happens at a sharp point?
The slope is like undefined.
Yeah, there's no slope. Okay? So these are just like the two obvious examples of when it doesn't apply. So our criteria, I feel like they're probably written down somewhere close. Yeah, not right there, okay. It must be on the next page. Criteria number 1. You have to have a continuous interval from A to B. Third picture had a gap, it wasn't continuous. I don't know where we want to, it's probably written on the next page, but I'm still writing it down anyway. Next page? Yeah, that makes sense. Okay, next criteria. This one didn't work because we had a spot where there was no slope. It's a sort of a challenge question, unless you're reading the criteria, then that's cheating. Do you remember what it's called when it has slopes? Differentiable, okay, perfect. Differentiable is the word that means it has slopes over this section. If there's a spot that doesn't have a slope, that is not differentiable at whatever. So, criteria number 2, differentiable from A to B. Now technically, what, we still have an argument on? Math something? I thought we had a math argument, that was pretty honest. I was excited for a second. You guys are lame. Technically, we don't even have to say criteria 1. If something is differentiable, that means it's guaranteed to have a slope and be continuous. So I wouldn't doubt if on the next page it only says differentiable, but it needs both of them. Okay? If these two things happen, if those two things happen, then we are guaranteed the average slope is equal to the instant slope at least once. Average slope is written down like f of b minus f of a over b minus a. That's the average slope, is equal to the instant slope. How do we write that with notation? Derivative. Look at that, you came in like partway through the lesson, you don't even know what's going on. Oh, you really don't know what's going on. Packet is on the bottom shelf down there, you're right, we did hand them out. Do you want to grab a second one for? Yeah, yeah, too. Oh, we haven't.
Yeah. Is that in winter?
And you put it
Yeah.
What's going on there? Okay. they will put a C. They're going to say f prime of C. And they're actually really specific about that. Like, they're more specific about that than anybody would actually expect them to be. So when you're doing these problems, you have to use a C, or they will not give you credit. So, the average slope is equal to the instant slope, and we put a C in there because at least one number, at least one location, is guaranteed that that's true. That's the mean value. What time do we get done?
27.
Oh, good, I got that. What?
You said it like obviously.
Even my brain doesn't remember a lot. It remembers math. I've had too many years of just math being forced into it. It knows math. I forget things that aren't important. I don't want to talk about rolls yet. I want to do an example. There it is. Use the table of values below to sketch the differentiable continuous function on the grid. All right, so it's just giving us numbers. So let's put those points on the graph. 0, 1. So like I said, most of the time this theorem is used on things where you don't have information in between. 0, 1, 2, 4. Wait, is it by ones on the bottom or twos? On the bottom as well?
Yeah.
Okay,
It's by one, by one.
I'm worried that I had half and half answers. It's by one, I got what you're saying. It's by ones, but they only label twos. Two, 4. 4, 8. 6, 12. I think you can just put it on the table. 6, 12, 7, 13, 9. This is actually really hard up close. 11, 8. Spencer, I'm worried that you are scheming something back there.
Please help me.
When I hear somebody whisper, you shut
Well, we're trying to get the FAA knocking at my door.
I feel like there's bots.
Not saying me personally.
Okay, do not connect them, FY. Oh, I already saw that. Do not connect them. You have no idea what happens in between the points. The only thing you know is those spots. Now, it tells us it's a continuous differentiable function, so all we know is that it's a smooth graph. We don't know that it goes directly between the spots. For all we know, it could make a huge roller coaster between the points at any location. Okay. Find the average rate of change of G from 2 to 9. I feel like this is a good time to have people come up here and write up. I was gonna have you roll. I didn't give it to you yet, even though it means nothing.
I get a picture.
Yeah, you get to roll, and then you pretend that that's them being rolled. This is what I do half the time anyway. I usually just roll it and just make up a number.
Wait. Never mind. Albert or Henry, I'm not sure.
See, that's exactly what I do. But nobody really catches on to that. Here you go. Okay, how do we draw the average rate of change from 2 to 9, which I know is kind of, I tried to move it so you could see the numbers at least.
It would just be dash line.
Whoa, why are we not drawing the point from the beginning to the end?
Okay, I'll move the other way then.
Oh,
You said 2 to 9?
yeah, you don't even, you were, You know this question too well that you don't even know what I'm trying to ask. I don't know. How come he did not draw the dotted line from the first point to the last point?
Because the interval stayed was 2 to 9.
Yeah. Okay, so that's important. You understood the question. You just, yeah. Okay, so he drew the dotted line between x equals 2 and x equals 9. That means we ignore everything outside of that. Okay? Good. How do we actually find the average slope, even though you drew it correctly, but how do we find that?
So we 4 minus 11 over 2 minus 9.
Yep.
Negative 7 over negative 7. That's negative 7.
Okay, erase what you just wrote, which is correct. And on your blue dotted line, write m equals 1. All right, sounds good. Perfect. You can put the pen down. Nice job. Okay, we found the average slope.
Wait, do you do
Can't hear you.
do you do B or A first?
It does not matter. If you do a minus b, then you just have to make sure that on both sides of the fraction you do the same order. You'll get the same answer no matter which one you put first. Okay, question 2, or B. Is g prime of 6 equal to the slope of the secant line from part A? Roll the dice.
Neil.
You're good at this. Now, as a tip, I would maybe have a longer delay between when the dice hits the pad and you yell the name.
Hey, can we get like a globe, like a fortune teller thing, so I can see people's fortunes? I mean, like, Neil is supposed to go up to the board, the fortune.
Kind of like that, Ian.
Like an 8-ball.
Now, they do actually make a dice that when you roll it will light up the number.
That's too fancy.
They do?
That is not too fancy. What I would love is one that has like 36 numbers. Like that would be super cool.
That would be sick.
Okay, Neil, you got rolled. Is g prime of 6 equal to the slope of, so is g prime of 6 have a slope of 1? Should we back up a second and ask what does g prime of 6 mean?
Yeah.
Oh, okay, well, you're answering it, but g prime means derivative. So the instant slope. So is the slope right at 6 a slope of 1? Hey, you're not Neil.
No.
Honestly, you can't say yes or no because you have no idea. We don't have an equation to go from. We don't have any way to actually find g prime of 6. So on this question, we would say like shoulder shrug. You have no idea, and you officially have no idea because you shouldn't know. Okay, there's our justification. I don't know, whatever you want to write. Good, that's a good answer. If you want to draw a shoulder shrug, you can do that. Hello. Hi. I can, but we were having fun drawing pictures on the board. Yes, okay, but, all right, he will have to forget that part. All right. Oh, that's true. Yep. Yep, okay. Daniel, you're excused from drawing pictures. Oh, yeah, the opposite, say whatever. You might as well just bring your stuff.
That's a good drawing.
Okay, we are gonna skip C because we didn't talk about Rolls-Theorem yet. I wanna do mean value theorem first. Oh, son of a gun. How about let's ask this question. since it's not listed down below, and I was assuming it was gonna be down below, but it's not. Much better.
Owens is it?
Owen, Owen, would the mean value theorem apply from x equals 2 to x equals 9?
Yes.
How come?
Well, actually, we
Oh,
might not know.
oh, oh dang.
Might not know. It might be indifferentiable at some point because we don't know.
Now, you have,
It does say indifferent, yet it would be.
you have a good train of thought there because you weren't sure, but it does tell us.
It does tell us it is differentiable and continuous.
Perfect.
Yes, it is applied.
When we were given the info, it says yes for all of that. Yep. Okay, so the mean value theorem would apply. One more person, and let's just make it the last person of the day.
Sebastian.
Huh, I don't think the dice even hit the
No,
map.
it did. It changed numbers from an
Yeah, I already
11
went.
to
We can't go twice.
That's actually true, that's double jeopardy.
Mila.
Neela,
Yeah,
oh, she's very invested.
okay.
Neela,
That was okay.
what would the mean value theorem guarantee us from what we just drew with that blue dotted line?
I don't know.
Oh my goodness. Did you write down the stuff on the previous page?
Yes.
I wrote it at the very
There's
top.
at least one C value.
One C value that guarantees what? I mean, what you said was good. There is a C value that guarantees that our function will have an instantaneous slope of 1, somewhere between 2 and 9. We don't know where, but we are guaranteed that at least one spot will. And that's it, that's all it says. Now, where this is more useful is if those 2 points have a slope of 0. Because where we're going to in this unit is slopes of 0 actually have a lot of uses. And so frequently we are going to look for slopes of 0. And as long as we're guaranteed one happens in between, it actually tells us a handful of things. So we know that there'd be one spot with a slope of 1 in between. Currently, that means nothing to us probably. That's okay. But as long as you guys understand that the mean value theorem is telling us this, that's what I want you to get out of today. That's it. We will continue on Monday. You guys had a test yesterday. I feel like it's pretty good not to have any work for the weekend. Shut your brain off.